Good afternoon. Rolling along here in 6.4 where we're going to multiply and divide these radical expressions. Okay, and this is just another nice lesson once you get the hang of the rules that we have to follow. And it's a little bit different than adding and subtracting them because we don't have to get the radicals to be the same. So let's just dive in and let's try this practice problem 1. This is 7 root 3 times 5 root 11. So we'll do them separately. So I could say 7 times 5 is 35. And then the square root of 3 times the square root of 11 is the square root of 33. And there's no simplifying I can do here with that square root of 33. You could actually do it in here when before they're multiplied together, do your simplifying. Okay, but such is not the case, and we're done. That's our answer for it. Practice problem 2. Well, this looks like a distributive property problem where I'm going to take the square root of 2 and multiply it to 3 times the square root of 5. So remember, there's like a 1 here on the outside, and it would be 1 times the 3 is 3. And then the square root of 2 times the square root of 5 is the square root of 10. And by golly, that's it for the first distribution. And now we're going to do the same thing when we subtract. 1 times negative 4 is going to be negative 4. That's minus 4. And square root of 2 times the square root of 2 is 2. Because the square root of 2 times the square root of 2 is the square root of 4. But the square root of 4 is 2. So this ends up becoming 4 times 2, which is 8. So my final answer would be 3 root 10 minus 8. And now we're done. Okay, so be careful when you're multiplying. This is a square. Remember that rule. Square root of 2 times the square root of 2 is 2. Like the square root of 100 times the square root of 100 equals 100. Okay, the number stays the same. Remember that little example here. And that's all this is. It's not related to the problem at all. This is just square root of 100 times the square root of 100 is 100. The square root of a times the square root of a equals a. So I just want you to get used to that habit and simplify your problem solving in the future. All right, practice problem 3. I have 2 binomials here. So that means I'm going to do what we called FOIL. They're different, so I can't do another shortcut way, which I may tell you about today. So here I've got the square root of 2 times the square root of 2 is 2, just like we mentioned earlier. And then outside is square root of 2 times negative 3 root 7. And that's going to be negative 3 root 14. And then inside here, I've got square root of 7 times the square root of 2 is positive square root of 14. And then how about last? Square root of 7 times negative 3 square root of 7. Well, that looks like it's going to be negative 1 times 3 is 3. And the square root of 7 times the square root of 7 is 7. Remember that we're multiplying that. So this ends up being minus 21. However, when I'm doing this so far, I'm going to have 2 minus 3 root 14 plus root 14 minus 21. And now let us simplify this. So I'm going to have my like terms combined. So I have 2 minus 21 is negative 19. And negative 3 root 14 plus 1 root 14 is going to be negative 2 root 14. And that's it. Done. That was a tougher problem, I think. Okay. Practice problem 4. All right, so this is what we've got. So now I'm going to show you, see if we are ready for a shortcut here, whenever you have a binomial squared. But first, before I do that, I'm going to do what this definition means. I'm going to cut the board in half here and work on this side of the board for this explanation. So what this means here is the square root of x plus 5 times the square root of x plus 5. All right, it's 2 of them. That's what that degree of 2 means. And then I'm going to FOIL this. All right? So just like I did the previous problem, I have the square root of x times the square root of x is x. And then I'm going to do the outside. Square root of x times 5 is positive 5 square root of x plus the inside, which is the same thing, 5 square root of x. Okay. And then we've got the last, which is 5 times 5, which is positive 25. So my final answer here is going to be x plus 5 root x plus 5 root x is 10 root x. And then plus 25 just comes along. I have no like terms to combine. So this is my answer when I expand it, then FOIL it. All right, now here's my, it's been around for years, a good number of years. The shortcut way of doing this. Whenever you have the binomial squared, okay, what you do is you can take the first term here, this square root of x, and then square it. The square root of x squared is x. Okay? And then my next, I'm going to erase what I just wrote there, I think. This circle anyway. Oop, get rid of that. I don't want any interference. That crazy phone. Okay, so now I've got the square root of x times the square root of x is x. That's the square root of x squared. So I'm squaring the first term. Then my middle term are going to be these 3 numbers that we see multiplied together. So this is 2 times 5, which is 10. 10 times the square root of x equals positive 10 square root of x. And then lastly, I'm going to square the 5. 5 squared is 25. And then this is my answer on the left side. And as you can see, they're the same. I get the same answer. I saved myself some steps by doing it this way. Okay, so I'll do another little something here. And that's, you can use on any of them. And that would be if I have a minus b squared. Okay, so I'm going to answer it now. I'm going to square the a, so that gives me a squared. I'm going to multiply 2 times a times negative b, and that's going to be negative 2ab. Just multiplying them together. And then I'm going to square the second term here, which is the b, and that's going to always be positive, so that's going to be plus b squared. And this will be your answer. So I urge you to practice some of these. It's really kind of neat. Maybe not with a radical sign, but if you did something like x plus 5, and if it's squared, then you could square the first term, multiply the 3 terms that you see, and square the second term, and you would be done. It only works for squares, not a binomial cubed or to the 4th power. It only works for the 2nd power. This little shortcut thing here. Okay, next problem. Here's another one, squared. Wow. All right, so let's do it this way here. This is a little mushier, if you will. So here, if I take 5 root A and square it. I'm squaring the first term. Okay? And that's going to give me, what's that going to give me? 5 squared is 25. A is going to be my first term. And then I'm going to multiply 2 times negative 3 times 5. Okay, so that's going to give me negative, what is that? Negative 30 square root of AB. Think about it. 2 times negative 3 is negative 6, times 5 is negative 30. There's my negative 30. Then I've got to multiply the square root of A times the square root of B. And then my last term here is going to be this negative 3 square root of B, like this, squared. So then this is always going to be positive when I square something. So that's going to be positive. 3 squared is 9. And then what have I got? Square root of B squared is going to be B. And there's no combining here now. So that's basically what my solution is going to end up being. Okay, so I got 25A minus 30 square root of AB plus 9B. And I did it that shortcut way. The other way is to, put them out together separately. That would be 2 of these. And I'll leave that to you to try, since I've given you the answer here, to compare it to. All right, next problem. Another one. Oh boy. A binomial squared. All right, so this is going to be the square root of x plus 3, square root of x plus 3 squared. I square the first term. And then my middle term is going to be negative 2 root x plus 3. So it's going to be minus 2 square root of x plus 3. And last is going to be negative 1 squared. I'll do it this way. Minus 1. No, I take that back. Minus 1 squared. It can't be that because I've got to have it out of the... let me think here a moment. Let me get my pen back. I think that's yellow. All right, so here I've got negative 1. Negative 1, that's what that is, squared. Because that term is always positive. So when I put it all together, I'm going to have the square root of x plus 3 squared is x plus 3. Minus the 2 root x plus 3, nothing I can do there. And then this negative 1 squared is going to be positive 1. Okay, now I can finish it off by combining my like terms. And I've got x, nothing going on with the x, and then 3 plus 1 is 4, so I could say plus 4 minus the 2 root x plus 3. Was that practice problem 6? So that's it. Done. I'm going to slide over here a moment and write that up again. Here I've got the square root of x plus 3 minus 1 times the same thing again. Square root of x plus 3 minus 1. And then same problem, only I'm going to FOIL it. Square root of x plus 3 times the square root of x plus 3 is x plus 3. Outside, square root of x plus 3 times negative 1 is negative square root of x plus 3. Inside, I've got the same thing, negative 1 minus 1 times the square root of x plus 3. Okay, I wrote the 1 here. I didn't have to. This one, because this represents the same thing, like -1. And then finally, -1 times -1 is +1. So again, I'm going to end up with what I had before. 3 and 1 is 4. I can combine those two. That gives me x plus 4 minus -1, and -1 is -2, root x plus 3. These are like terms, and I'm combining them. So it's minus square root of x plus 3. And again, same answer I got before. There it is there. All right. Did it both ways. So, whatever you're comfortable doing, this isn't a race. This is not, I repeat, this is not a race. Okay. Practice problem 7. I'm going to multiply the sum and the difference of the same two terms. All right, if I do it like so, I've got the square root of 5 times the square root of 5 is 5. Outside is square root of 5 times negative square root of 3, which is negative square root of 15. And then inside, I've got the same thing just about, but it's positive square root of 3 times the square root of 5. That's going to be positive square root of 15. And then finally, square root of 3 times the negative square root of 3 is negative 3. Square root of 3 times the square root of 3 is square root of 9. Square root of 9 is 3. All right, then let's add our like terms up and that sort of thing. So I got 5 minus 3, and that's 2. And then negative square root of 15 plus square root of 15 is 0. So I'm just left with 2 is my answer. And I think that's kind of fun. Different. All right, that's practice problem 7. And now we're going to go into dividing radical expressions. And this has to do with remembering one word, which is rationalize. Rationalize the denominator. Sorry about the clicking going on there. Okay, so there it is, and I'm going to rationalize the denominator. So let's do that. And I kind of got in the way there, so I guess that's not necessary to have that. That's my clue when we're dividing. Whenever we can, we rationalize the denominator, get the radical out from under the radical sign. All right, so what do I do here? I'm going to rationalize the denominator by multiplying top and bottom by the square root of 7 plus the square root of 3. If this is minus, then I'm going to use addition in the multiplier on the outside. So remember, I have to do it top and bottom too. So it's square root of 7 plus square root of 3. All right, so what's going to happen here is what happened in our last example. Watch. Square root of 7 times the square root of 7 is 7. Outside and inside, they're going to end up canceling. So here I've got positive square root of 21. And then the inside here is negative square root of 21. And then what is last going to be? It's going to be minus 3. So what I end up here in my denominator now is 4. So this is going to equal 4 in the denominator. 7 minus 4 is 3. Okay, and then let's see, what do we got here on top? 3, I got to distribute that to the top. 3 times the square root of 7 is 3 root 7 plus 3 times the square root of root 3. No, 3 times the square root of 3 is 3 root 3. And there's nothing I can do with that. To simplify it, I could take a 3 out, but that's not going to help with simplifying it all. So this would be my final answer for that one. Okay. How about this one, number 9? Why am I yelling? Okay, so I'm going to rationalize the denominator. That's the square root of 10 minus 3, top and bottom. Square root of 10 minus 3. Multiply. All right, so let's figure out the denominator. We'll try it this way. Square root of 10 times the square root of 10 is 10. Remember, they're the opposites now. That's why the rationalizing is all about. So now I'm going to have the opposite is going to be square root of 10 times negative 3 is negative 3 root 10. And then the inside is 3 times root 10, which is positive 3 root 10. So I know those are going to cancel out. Then finally, 3 times negative 3 is negative 9. So these two cancel out, and I got 10 minus 9, which is 1. And then I'm going to FOIL the top now. And now this time they're the same. So let's see what I can do here. Let's see if I can squish it in here. Square root of 10 times the square root of 10 is 10. Outside is square root of 10 times negative 3 is negative 3 root 10. Inside is the same thing. Negative 3 times the square root of 10 is negative 3 root 10. Okay, that's different. I've got a middle term now. And lastly, I've got negative 3 times negative 3, which is positive 9. So what I end up here on the top is, let's bring it down here. I'm going to have 10 plus 9, which is 19. And then I have negative 3 root 10 minus 3 root 10, which is minus 6 root 10. And I'm done. I can't simplify that at all. It's over 1, but, we're good. Was that number 9? That was example 9. So that's it. Now there's one kind of problem they're not talking to us about. So I've got to find that. That's kind of like something you want to know what to do with. Hold on 1 second. I got one more example. This is it. Example 8 in the textbook, page 546. Okay, and let's see. So if I rationalize the denominator plus the square root of 3, I have this, and I'm multiplying top and bottom by, Okay, so here I'm going to have 5 times 5 is square root of 5 times square root of 5 times the square root of 5 is 5. Then outside and inside, those are going to cancel because they're the sum and the difference of the same two terms. And I hope you get that. So I've got positive square root of 15 minus the square root of 15. So those are going to end up canceling out. And then finally I have negative square root of 3 times the square root of 3, which is minus 3. Okay, so inevitably I get 2 as my denominator. I'll put it here for now. Then I've got to distribute the 6 times the 5, square root of 5, like this. Distribute this way. So that's going to give me 6 root 5 plus 6 root 3. And this is where we're at thus far. But now what I want to do is I want to simplify this a little bit more. So one of two things I could do. I could separate it and write this up as 6 root 5 divided by 2 plus 6 root 3 divided by 2. And then I could simplify each of these. 2 goes into 2 once, 2 goes into 6 3 times, so the first one's going to be 3 root 5 plus 6 divided by 2, or I like saying 2 goes into 2 once, 2 goes into 6 3 times, and then I've got 3 root 3. And then I'm done with that. Okay. Let's see here if I can dig this out. If I start from here and do that same deal that I just did a moment ago, then I could actually factor out, I could factor out the 6 from this, in this numerator. And if I did, I'd take the 6 out and I would put back the square root of, my goodness, the square root of 5 plus the square root of 3. And that would all be over 2. So then in that case, if I'm doing it this way, which you can, 2 goes into 2 once, 2 goes into 6 3 times. And then you could take the 3 and distribute it over the square root of 5 and the square root of 3. And that's going to give you the same thing we have over here. So this is equal to this. They're now equal to each other. But I think this is more the simplified form of what they're looking for. It changes from book to book, depending on what book you're using. All right, that's it for today. That is section 6.4. And I think we're ready for a quiz on this or so. I'll let you know. I think I made a little mistake in the schedule, but I will let you know. All right, take care.